In Ukraine, an FPV drone detonates against the windshield of an armored vehicle, and the footage captures the entire strike from inside the cab. The drone flashes into view and slams into the glass, leaving a web of small cracks across the windshield. The exact date and location of the hit remain unclear from the footage alone, but the clip surfaced recently on Reddit. It was described as first-person footage from inside a Ukrainian Iveco LMV struck by a Russian FPV drone. In Ukraine, FPV drones have become a familiar threat. They fly low, approach from unexpected angles, and strike with little warning. Vehicles like the Iveco, meanwhile, handle the routine but essential movement that keeps an army working, such as carrying troops, supplies, and small teams through terrain where heavier armor is impractical. The problem is that an FPV drone does not behave like a conventional round. It's slower, usually in the 60 to 100 mile/hour range, but it arrives with blast and fragmentation, rather than a single penetrating round. Instead of one concentrated impact, it can hit with the strike itself, the detonation, and a spray of debris all at once, and it only needs to come into close enough contact with a vulnerable surface, such as glass, seams, or exposed equipment, to cause serious damage. The Iveco LMV, also known as the Lince, is a light armored 4x4, designed more for patrols, mobility, and survivability, rather than sheer weight. Depending on the version, it weighs around 15,600 to 18,700 pounds. This is several times heavier than a standard passenger car, but nowhere near the 60 to 70 tons of a main battle tank. In weight terms, it sits much closer to a heavy commercial truck. It's also about 7.2 feet across and can go faster than 80 miles/hour on the road. Because the crew has to see where they're driving and still survive this kind of hit, the window cannot be ordinary glass. It is transparent armor, a layered laminate with hard outer faces and softer inner backing, built to absorb impacts that would punch straight through a normal windshield. The crack pattern shows how the laminate breaks in a controlled way and still holds together enough to keep the crew protected. In vehicles like this, that protection is often rated under NATO's STANAG 4569 system, which measures armored vehicle ballistic resistance. At level 3, that standard is meant to stop 7.62 by 51mm armor-piercing rounds at about 100 feet, traveling at just over 3,000 feet per second. In this case, the outer layer shatters to spread the force. Behind it, the inner laminate, often backed by polycarbonate, flexes and catches fragments, preventing the cab from filling with shards and spall. Transparent armor like this has been standard on protected patrol vehicles for years. The LMV family has been fielded at scale, with more than 4,000 vehicles sold worldwide. Designed to survive ambushes, fragmentation, and small arms fire, rather than trade blows with tanks. There's also an uncomfortable economic reality in the frame. The drone delivering that hit may cost around $400 in many Ukrainian FPV builds. A bullet-resistant windshield, by contrast, can cost anywhere from roughly $4,000 to $18,000 on its own, before even getting into a full armored glazing package. And the vehicle behind that glass is not cheap either. Public figures have put the Iveco LMV itself at around $405,000, before mission kits, radios, optics, and whatever additional protection the vehicle may be carrying. For the crew inside that cab, the math looks different. The drone is cheap. The windshield is not. The laminate did its job. It spread the force, caught the fragments, and held. The crew watched their windshield crack and got to drive home anyway. A piece of one of the most advanced missile defense systems on Earth lies in the sand. It's not shattered nor vaporized. Instead, it's intact enough to study. And that is the problem. What this footage appears to show is part of a THAAD interceptor, the U.S. military's terminal high-altitude area defense system for shooting down ballistic missiles in the final phase of flight, at high altitude or just beyond it. It appears to have come down near Suwaida in southern Syria, not far from both the Jordanian border and Israel. The piece seen here appears to be part of the interceptor's front-end guidance section, the part that races into the target in the final seconds. This is not a traditional missile warhead, as it carries no explosive charge. Everything depends on direct impact and pure kinetic energy. While something like a Patriot can destroy a target with a fragmentation warhead, THAAD is far less forgiving. At intercept speed, the collision is meant to destroy both objects, leaving little worth recovering. So what the footage is showing is an unlikely and decidedly unintended occurrence. THAAD is not a simple piece of hardware. A full interceptor is about 20 feet 3 inches long, weighs roughly 2,000 pounds, can reach speeds of around 6,300 miles per hour, and is designed to hit targets at ranges of about 120 miles and altitudes up to roughly 93 miles. More recent figures put a THAAD interceptor at about $12.3 million each, compared with about $9.5 million to $11.2 million in earlier lots. A big part of what drives that complexity is the front-end guidance section, which includes an infrared seeker that follows a target's heat instead of depending only on radar. It is built to pick out a real warhead from clutter, debris, and decoys while closing at several times the speed of a rifle round. More specifically, it uses passive infrared guidance, which avoids the radio frequency jamming problems of radar-guided systems and is less affected by decoys that only mimic radar signatures. Before launch, THAAD interceptors are cued either by the system's own ANTPY-2 radar or by offboard sensors through the command, control, battle management, and communications network. After launch, the front-end guidance section separates from the booster, and the protective shroud breaks away, exposing the seeker for the final chase. Behind that is the Divert and Attitude Control System, or DAX, a ring of tiny rocket thrusters that steer the interceptor in space, where every correction has to come from bursts of thrust. According to L3 Harris, one of the defense contractors behind the system, the DAX uses 6 thrusters for roll, pitch, and yaw control, plus 4 divert thrusters for the short, forceful corrections needed during the final approach. When a section like this is recovered, it gives whoever has it a chance to look closely at how the system works, how it sees, how it steers, and what it's built from, including the seeker window, the thruster layout, the thermal protection, the materials near the nozzles, and the overall shape of the sensor head. Even with damaged electronics, the intelligence value is still there. The hardware alone can reveal performance limits, material choices, and the physical constraints that shape how the interceptor tracks and maneuvers. That probably would not be enough to replicate that from scratch, but could give a much clearer picture of the interceptor's actual performance limits. Still, for countries like Russia and China, with mature foreign material exploitation and reverse engineering capabilities, it could be enough to sharpen countermeasures, develop decoys, conduct materials research, and conduct more realistic testing against the system. Hardware like this is never supposed to survive intact. When it does, whoever finds it first wins. And by the time this footage surfaced, that window had already closed in Syria. Footage from an attack at Novorossiysk, a key Russian port on the Black Sea, shows something beyond a drone strike. It appears to capture a warship's defensive picture being pushed into confusion under live attack. In footage published by UA News, anti-air fire cuts through the night as repeated explosions flash around the port, suggesting a defense system struggling to keep up with too many threats at once. Ukraine publicly claimed responsibility for the attack, and multiple reports said its unmanned systems forces struck Admiral Makarov during the night of April 5th through 6th, 2026. Novorossiysk was put on air raid alert. Local officials acknowledged the attack. The port reportedly took serious hits, particularly the Sheshkaris oil terminal, where a fire broke out after several explosions. Regional authorities described the damage more narrowly as debris falling on 2 industrial facilities, but the footage shows multiple explosions across the port, pointing to a much broader attack. The main objective appears to be Admiral Makarov, a modern frigate roughly 409 feet long and displacing around 4,000 tons, and one of the port's most important defensive nodes. More importantly, it appears to have been targeted because it was built around a layered defensive architecture. The Steel 1 air defense system, 24 vertical launch missiles and two 12-cell 3S-90M launchers, surveillance and illumination radars, electronic warfare systems, and close-in guns designed to handle more conventional aerial threats. Systems like this were built to fight aircraft, anti-ship missiles, and other fast, relatively legible targets. A subsonic cruise missile at around Mach 0.8 or 0.9 is dangerous, but it's still a comparatively legible problem for the ship's defenses. A drone swarm is not. Under that kind of attack, the ship is no longer dealing with a single clean track, but with low-profile surface drones riding the waterline, aerial drones approaching from another axis, wave clutter, reflections from port infrastructure, and fires throwing heat and smoke into the background. Its defenses start with the Fregat M2M, which is a capable radar, but its design traces back to late Cold War-era concepts, later modernized for post-Soviet ships. It wasn't built for an environment where slow, low-cost threats make it work through wave clutter, thermal noise, and attacks coming from multiple directions. Situations like this strain the entire engagement chain, because Steel 1 still has to guide interceptors onto real targets inside that cluttered picture. That depends on the OREC target illumination radars mounted around the superstructure. Fregat handles broad search and tracking, but the final intercept still depends on OREC radars illuminating the target for the ship's 9 M317 ME missiles. There are only 4 of them, so even if part of that radar chain is degraded, the ship's engagement capacity narrows fast. And with only 24 Steel 1 missiles aboard, every bad engagement decision also becomes a magazine problem. The exact mix of drones used against Admiral Makarov remains unclear. Some reports say 2 strike drones damaged the frigate, but that has not been publicly confirmed. Even so, the ship does still have a last-ditch fallback in its 2 AK-630 close-in weapon systems. But if the fight is collapsing to that layer, the defense is already in a much more chaotic place than it was designed to handle. So far, there's no clear public indication that the frigate sank, but that may be beside the point. Ukraine does not have to sink a frigate to make the strike count. It only has to leave a major Black Sea Fleet asset slower to react, less certain in what it sees, and already under strain before the next raid. Novorossiysk is one of the fleet's key fallback bases after repeated pressure on Crimea. In this kind of war, blurring one ship's picture of the fight may be enough to make that side lose the next exchange. A U.S. Air Force KC-135 tanker just landed at RAF Mildenhall, covered in scars. Open-source observers identified it as part of the Ohio Air National Guard, arriving on April 12th with its fuselage studded in battle-damage repair patches. These temporary metal fixes seal shrapnel holes across the aircraft's skin. Such damage was not sustained as the aircraft was at the front. It was sustained at Prince Sultan Air Base in Saudi Arabia, roughly 400 miles from Iran, deep enough inland that the base was long treated as rear area infrastructure. For decades, U.S. Airpower worked on a pretty simple idea: push the most valuable support aircraft far enough back, and they'd be relatively secure. Distance, geography, layered air defenses, and hardened operating procedures were all supposed to keep them safe. Iran just broke that belief, and the evidence is sitting in plain view on the aircraft's side. According to broader reporting, at least 5 KC-135s were damaged in the strike. Images published afterward showed U.S. aircraft dispersed around the base in what appeared to be an effort to reduce losses from follow-on attacks. The weapon doing that kind of damage was a Shahed 136, a slow, one-way attack drone that can carry roughly 100 pounds of explosive, more than 1,200 miles to the target. It is smaller than a compact car, slower than many highway vehicles, and radically less impressive than the aircraft it threatens. But for this kind of mission, it does not need to dogfight, outrun anything, or survive. It only needs to get close to the target. The damage pattern is spread unevenly across the KC-135's fuselage, which better fits fragmentation than a direct strike. It looks more like the kind of effect achieved when a warhead goes off close by, or when multiple drones pepper the area with shrapnel. This suggests something beyond a single successful strike. It suggests a saturation problem. Once drones arrive in groups, The defender is no longer dealing with isolated targets, but with volume. Whether the number is 10, 20, or 50, every leak in the defensive net begins to matter. Long-range drones turn what used to be a distance problem into a volume problem. And when the target is a tanker, the damage is larger than the airframe itself. A KC-135 can carry up to 200,000 pounds of transferable fuel, which is what allows fighters to push farther and remain on station longer. What's being damaged is range, persistence, and sortie generation. On an aircraft like this, the scars do more than mark damage. They show that distance alone is no longer enough to sustain the systems that enable long-range air power. Even so, number 591444 still made it all the way to RAF Mildenhall with temporary repairs on its fuselage. That suggests damage serious enough to leave visible scars, but not catastrophic enough to compromise the aircraft structurally. The jet could still fly, but it also suggests something else. Repairing it in theater may have been judged less desirable than moving it out. Tehran has said little. Washington has said less.